Okay, good morning. Welcome to
SuperMath164.
SuperMath164. Accidentally called your brother's video SuperMath today. This is a math counts problem we saw in our art problem solving geometry book. A soccer ball is constructed with 32 regular polygons with equal side lengths. 12 are pentagons and the rest are hexagons. A seam is sewn when two edges meet. What is the number of seams in the soccer ball? And I underlined that seam because that sentence here is really defining the word seam. Here, I mean, they could have called it, turtle. A turtle is sewn when two edges meet. What's the number of turtles in the soccer ball? So that's just a definition for this problem of what seam is. Let me ask, before you jump in, I want to ask you a couple questions. First, do you understand the problem?
Yeah.
Okay. Second, what kind of problem is this?
Well, it's from math counts, so it should be a snap problem.
Well, maybe. It might be a snap problem. But what kind of math is being asked about in this problem?
Well, it's counting.
Yeah.
Because you have to figure out how many overlaps there are.
This looks like a geometry problem.
But it's a counting problem.
But it's also a counting problem. Okay. Good. I'm very interested to see how you approach this.
Well, if we draw an intersection, the seam is here.
Yep.
And from this picture, at least, it looks like the seam is sewn to where two edges meet, but it looks like each seam is going to be shared by two polygons.
Okay.
But we also have to figure out how the pentagons and hexagons are spaced in the soccer ball. Well, if we don't correct for overcounting, we're going to have five seams per pentagon and 6 seams per hexagon.
Okay.
So we have 12 pentagons, 60 plus 20 hexagons. There's 180 seams.
Sorry.
And this is without correcting for overcounting.
Yeah. Okay.
But since each seam is shared by two shapes here, I think there's going to be 90 seams.
Okay. Interesting. But you said you have to figure out the picture of what a soccer ball looks like.
Too bad we don't have one in here.
Yeah, too bad we don't have one in here. So I want to ask you. You came up with an answer of 90 seams, but you didn't draw a picture of a soccer ball, so you don't know for sure how the hexagons intersect and how the pentagons intersect. You're just not sure about that.
Yeah.
So what do you think?
Well, I think that it doesn't matter.
Why?
Because maybe like on the math counts test, no one's going to have a soccer ball with them.
Well, that's true. That's true. But forgetting that it's a math counts problem and no one has any soccer balls with them, why do you think it doesn't matter?
Because the seams are always going to be joined. There's never going to be 3 polygons sharing one seam.
Okay. So what does that mean?
So that means that there's always going to be 2 polygons sharing the seam, so it doesn't matter where you space them out.
You just space them out, however they get spaced out. Every edge, when you count all the edges, you count every seam twice, because there's never 3 polygons sharing the same side. So there you go, 90. What looks like a very tricky geometry problem if you have to try to draw it all and count them up. Comes down to a very clever counting argument, funny enough.
Mm-hmm.
Good job. Good work on that problem. Very good job.